Okay, so the key thing in here is that remember that the gradient, okay, the gradient of the curve, okay, at a point is the angle that the tangent line makes. So a tangent line is where a line touches the curve. So it's hard to see in here, but my tangent line is that point. The gradient where that green line touches the blue line, the gradients are the same. So that's the key element of this. If we're looking for a tangent line, it means that the line and the tangent line have the same gradient at that point, okay? And so then if we want to work out the gradient of that tangent line, so I'm doing that, I'm looking for the rise over the run of that green line there. That will give me the gradient of that line, yeah? And so the gradient of that line, the gradient, M, is equal to rise over run, which in this case is opposite over adjacent. And we know that opposite over adjacent is the same as tan theta. So that's where we get the concept that the gradient of the line is the same as tan of the angle that the tangent makes, okay? So if we have a look at a couple of examples, find the coordinates of the points on the curve with equation y equals at which the tangent makes an angle of 45 degrees. So if the curve makes an angle of 45 degrees, so tan of 45 degrees is equal to 1. So in other words, where is gradient equal to 1? So I want to try and find when the gradient is 1. So what do I know about the gradient? Well, that's what the derivative is. And that's the key big skill. The gradient is equal to dy dx, which in this instance is 2x minus 7. So I want to know when that gradient is equal to 1. Okay, so if I now solve dy dx equal to 1, 2x minus 7 is equal to 1. So x is equal to, since we need the coordinate, we're going to have at x equal to 4, y is equal to, sub it into the equation, 4 squared minus 7 times 4 plus 8. What's that? 16 minus 28 plus 8, which equals negative 4. So the coordinate is the point 4, negative 4, where the line touches. Okay, we might put a graph up in a minute showing us exactly what that means. All right, so let's go to example 2 now. We'll try and keep some room for a graph. So we might go down in here. All right, so same sort of thing, except this time I want to know whereabouts will this curve of x squared minus 7x plus 8 have a tangent line that is parallel to 2x plus y equal to 6. So in other words, if we consider 2x plus y equal to 6, that's y equal to 6 minus 2x. So the gradient of that line is equal to negative 2. So in other words, we're saying, whereabouts does my equation, where does my parabola have a gradient of negative 2? So I need the gradient of the parabola equal to negative 2. Therefore, it's saying solve dy dx equal to negative 2. All right. When is the derivative equal to negative 2? So what is dy dx? Well, dy dx from our earlier example is 2x minus 7. So I'll have 2x is equal to 5, x equal to 5 on 2. So the y coordinate there, 5 on 2 squared minus 7 times 5 on 2 plus 8. So we'll get 25 on 4 minus 35 on 2. So I'm going to put minus 70 on 4 plus 8, which is 32 on 4. So 25 plus 32 is 57 minus 70. What's that? 13. Yeah. So the coordinate I'm interested in is the point 5 on 2, negative 13 on 4. Okay, so let's put a graph in and let's just try and make sense of all this. So if we just have a quick look at the graph that we've got here, you can see that, oh, we don't want to do that. All right, so if we consider the black line as a parabola, okay, let's just get a marker up. The black line is our parabola. And so the first equation, there's my blue tangent line here. And so what we're saying is that this line here, at the point that we're interested in, which we haven't actually marked, or I haven't marked, at the point 4, negative 4, the gradient of that line is 45 degrees. So what we're saying is if I was to draw a horizontal line that is parallel to the x-axis, or if I was to extend this line all the way up to the x-axis, that angle there is 45 degrees, okay, which is the angle of the tangent line or the gradient of the line. So that's the angle of the gradient at that point, all right? For the second equation or question, this orange line, that's the line of 2x plus y equal to 6. And what I was interested in was finding the point that was parallel to 2x plus y equal to 6. So this red line here, okay, the gradient at that point there, 2.5, negative 3.25, which is our 5 on 2, negative 13 on 4, the gradient of the line at that point is parallel to, or the same as, the gradient of 2x plus y equal to 6, I should say, equal to 6. Okay, so that's what we're sort of doing. So as soon as we start working with gradients, it means I need a rule that involves a gradient or represents the gradient. And a rule that represents the gradient is always a derivative. Okay, so let's have a look at our last question here. The curve with the equation y equals ax squared plus bx has a tangent with gradient 3 at the point 1, 1. Find the values of a and b. Okay, so first things first. So we're going to find a and b, so I need 2 bits of information. So we've got some rule, who knows, ax squared plus bx plus c. And what we're saying is at the point 1, 1, the gradient of the line is equal to 3, the rise over the run. Okay, so two things first. First things first, the curve goes through the point 1, 1. So that has to satisfy the equation. All right, so therefore, if I sub the point 1, 1 in, I get y is equal to a times the x value. So y was 1. I get equation, there's one equation there. Now the second equation tells me at the point x equal to 1. So the other bit of information I know, at x equal to 1, the gradient is equal to positive 3. So what that means is that at x equal to 1, the gradient, or dy dx, is equal to 3. So if I work out the derivative, dy dx is equal to 2 comes out the front, multiplies ax, because a is a constant, plus b. All right. And if I now substitute the point x equal to 1 in, the derivative is equal to 3. So 3 is equal to 2a times 1 plus b. So 3 is equal to 2a plus b. There's equation 2. So now, if I solve simultaneously, I get a plus b is equal to 1. 2a plus b equals 3. Subtract the two equations. 2a minus a is a, b minus b is 0. 3 minus 1 is 2. So I get a is equal to 2. Substitute into one of those equations, b must be equal to negative 1. So the rule y equals, a was equal to, what does a was? A is equal to 2x squared minus x. Okay, so that's the equation. Find the coordinates of the points where the gradient is 0. Right, so I've got my rule. So now for part B, I need the gradient equal to 0. So with this rule, what about this rule relates to gradient? The derivative. So dy dx is equal to 4x minus 1. I want to solve that equal to 0. So x is equal to a quarter. The coordinate. So at x equal to a quarter, y will equal, substitute a quarter into the rule, 2 times 1/4 squared minus a quarter, which is 2 times 1/16 minus 1/4, which is 2 1/16, which is 1/8, minus 2/8, which is negative 1/8. So the point I'm interested in is 1/4 negative 1/8. There's our answer down there, which suggests that maybe my a equal to 2 and b equal to negative 1 is correct. All right. Yeah, righto. Off we go.